Welcome to the second part in a two-part series of how to build your own voting dApp using SmartPy and using React. In the first part of this tutorial, we covered how you use SmartPy within the SmartPy web IDE to write a simple smart contract that allows users of your application to vote for their favorite footballers of the year. In this second part of this series, we would get into how you write the front-end part of the application using React. You can follow along with this tutorial by reading the blog in the description below. To follow along, simply open up your favorite code editor. I'm going to be using VS Code for this tutorial. Navigate into your terminal, paste the git clone command, and this is going to clone the project from my GitHub repo. And now we can simply cd into the project. And once you're in here, run the command npm install, and this will run all the libraries that we need for this project. We're going to be installing the Beacon wallet, which allows our dApp application to interact with the user's wallet. And we're also going to be installing the Taketo library, which allows us to interact with the Tezos blockchain from our clients. The first step is we need to open this up. Once you have your project open up, navigate to the source folder, create a new folder, and let's call it helpers. And right inside helpers, let's create a file called constants.js. This is going to simply hold our constant variables that we're going to use within the application. Let's make sure that everything works. Open up your terminal and simply run npm run dev, and this will run the application so we can confirm that everything works correctly. Now, if you navigate to your browser and go to localhost 3000, you should see that your project loads correctly. Now we need to define two constants. We're going to need the RPC URL, and we're also going to need the smart contract address that we deployed in the first part of this tutorial. For the RPC URL, just going to paste that in here. An RPC is simply a way for us to connect to a node on the blockchain. So ICAD, for example, is offering us a URL that we can use to proxy into a node on the blockchain and for us to be able to read data from that node. Our contract address is going to come from our smart contract, which we deployed in our last application. Now we're just simply going to paste our smart contract address in. And lastly, once we're done writing, defining our variables for our RPC URL and our contract address, we need to export these two variables so that we can access that on our front end. And we're going to start walking through the code. So we want to import all the libraries that we're going to need to proceed. So let's walk through each of the libraries that we've imported here. We've got the Beacon wallet. A Beacon allows us to connect to the wallet installed within the user's browser. So if they've got a Chrome extension of a Temple wallet, Beacon wallet would allow us to connect to that wallet and be able to interact with that wallet. Next thing, we've got Tezos toolkit from Taketo. So Taketo allows us to interact with the Tezos blockchain directly. So we can read data on the blockchain, we can send data to the blockchain, we can interact with the blockchain essentially. Now, we're also going to import our contract address and our RPC URL. The contract address is the address of the smart contract that we've deployed on Tezos, and the RPC URL is the RPC that were being provided by the ICAD team connect to a node on the Tezos blockchain. We're also going to bring in use effect, use state, and use ref. If you're familiar with React, you're also going to be familiar with the concepts of use state, use effect, and use ref. The first thing that we need to do is we need to initialize a Tezos instance, and we can simply do that by writing Tezos equals new Tezos toolkit, which is from the Taketo library, and we also pass in the RPC URL in here. This way we initialize a connection to a node on the blockchain. Next, we need to make sure that we can keep track of the state within our application. And to do that, we're going to call use state. So we're going to have a state for players, which are all the players that users can vote for within our application. We're also going to have a state for reload, so that when a user has casted their vote, the application can simply know to reload itself and show the latest data on the screen. We're also going to have a state for messages. So this is going to be for our error messages or for any message that we want to display to the user within the application. Next, we're going to set a reference to the user's wallet. So if a user's wallet instance has been initiated within our application, we want to be able to keep that state. And so we're going to use ref to keep that state. So we're going to write the connect wallet function that allows us to connect to the user's wallet within our application. It's an asynchronous function, so we also need to await a couple of responses from the RPC node. As you can see, the first thing that we do is we have an options variable defined here, which takes an object. And we've passed in the name of our application, which is Tezos. And we've also defined the network that we want to interact with, which is the ghostnet. Then we create a new instance of Beacon Wallet, and then we store the user's wallet instance in a walletref.current. We check that the user has given us permissions to their wallet, and once we've gotten permission to the user's wallet, we can call the setProvider method on our Tezos instance. Next, we're going to have another function that allows the users to disconnect their wallet from the application. So maybe they want to vote using a different wallet and switch away from a previously connected wallet. So we're going to write a disconnect wallet function, and this function will simply check if the wallet is disconnected. If it's not, it's going to call the clearActiveAccount method to disconnect that wallet. The next step is we need to get a list of players from the storage. So we have on the blockchain, we've already stored a list of the players that users can vote for within our application, and we need to be able to access that storage to be able to display it on the front end of our application or of our dApp. Now, to do that, we're going to write a getPlayers function. So let's walk through the getPlayers function. Again, we're going to tap into our Tezos instance, and we're going to check for what is happening at this contract address that we've defined earlier in our constants. We're going to check for the storage. Then we're going to open up an array of players. So this if storage here checks that we're able to successfully connect to the contract storage. And then we check for the players in the storage. And then we push all of that into the array of players up here. So we're going to give each player ID a key. We're going to call the name, the year, and then the number of votes that the player has received. Once all of that has been pushed into our players array, we're going to set players from up here. We already have a status of players here. We're going to call set players, and we're going to pass the players into the set players state. Now, the next function that we want to create is a function that allows us to send a transaction to the blockchain. In other words, a function that allows our users to vote for their favorite player. For a user to vote for their favorite player, first we need to connect to their wallet. And we already have the connect wallet function up here. So we're going to call that again, connect wallet. And then again, we're going to connect to the contract. And we're going to simply call the increase votes method, which is already now part of our smart contract. And we're going to pass the player ID that this user wants to vote for, and then we're going to send the transaction. We're also going to show a message on the screen letting the users know that we're awaiting confirmation from the blockchain. And once we've gone through 2 blocks, and that's why we have 2 passed in here, once we've gone through 2 blocks, the blockchain is going to give us a hash for that transaction. And we're going to take that hash and simply display a message to the user, letting them know that their vote has been cast and the vote has been confirmed. Now we're going to get into the use effect part of our application. So when our application loads, we want to be able to load the list of players that are in our storage on the blockchain. And so we're going to use a use effect for that. So when the application loads, we're going to call use effect, and we're going to call our getPlayers function that we've defined initially. Once the vote has been cast, we want to set reload to true, which is what we've done here. And once reload is true, we want our application to reload its state again so that we can display the latest votes to our users. And that's why we've got load here as part of the dependency array in our use effect. And we set reload back to false. So once the application has reloaded, we call getPlayers again, and then we set reload back to false. Now, with all of that done, we can start to make changes to the HTML part of our application or to the part that the users interact with. So let's get into that. So we're going to take out everything that we've got in here for now. And we're going to start to write this again. The first thing that we need to do, let's give our application a title. And once we have the title, we're going to call it Tezos. And now we're going to map through the players. So we're going to first check here if the players array actually contains any players. And if the players array contains players, we're simply going to map through each player within the players array. And we're going to pass their player ID, we're going to pass their name, and we're going to pass the number of votes that they've received. Then we're also going to pass a function to onClick function. We already have the vote player function defined up here. So if I scroll up here, you'll be able to see the vote player function, right? And it takes a parameter of player ID, which is exactly what we're passing in here. So we're going to call the vote player function, and we're going to pass player ID to it. So that when a user clicks on the button to vote, the vote player function is going to run. Next step, we're going to have a paragraph that also displays messages to our users so that they can know the state of our application. And lastly, we're going to have a disconnect wallet function so that when users are done with voting, or if they want to vote from a different wallet, they can simply disconnect a previously connected wallet and then connect a new wallet for them to cast their vote. And that's it. We're done with writing the front-end part of our application. Let's take a look at what it looks like. Now, if we can navigate to the front end of our application with localhost 3000, we can see that we've got all our players from the storage, from our smart contract. We've got our disconnect wallet button that we can also click on as well. So now let's try to make sure that our application works correctly. Let's try to cast a vote for any of the players here. So we'll click on vote. Once again, it's going to bring up our Tempo wallet. Remember that we're using Beacon wallet to connect in here. I'm going to click account 7. I'm going to click connect. I'm going to click confirm. And once I click confirm, you can see our message here awaiting confirmation. So we're still going to await confirmation for a little bit while we wait for the transaction to be added to the blockchain. And now you can see that once that's been added, you can see vote confirmed, and you can see that our application automatically reloads and adds one vote for Lionel Messi here. And that's how you create a simple voting dApp using React on the front end and using SmartPy to write your smart contract. Remember to read the full blog for more information about everything that we've covered in this two-part series.